Bloom and Billet Mill was built in the early 70s by Davey United as part of Scunthorpe's Anchor project and is over a mile long. The mill rolled its first ingot on Friday the 12th of January 1973 and quickly moved on to full 21-shift operations by December of that year. The first millionth ton was rolled in March 1974, and the mill continued with 21-shift operations until April 2004. Mill closure was announced in February 2005. Initially fed solely by ingot root material, this changed in October 1981 when the first Bloom cast was rolled. Following the cessation of ingot production in November 2000, the mill feedstock became nearly exclusively of Bloom caster origin. Blooms are brought on flats from the caster and set into the soaker bay in an area predetermined by the soaker controller. They're then picked up off the flats in the tongs of a VIC crane and charged into the soaking pit according to the instructions given by the soaker controller. Blooms are heated in the pits and then soaked at a temperature and time determined by their quality. 1305 degrees for leaded free cutting and 1275 degrees for tire cords, for example. Once the steel is judged ready to roll, the VIC starts to draw the blooms from the pit and set them on the ingot buggy. Note that the bloom is slewed so as to present a good front end to the mill. Once loaded on the buggy, the bloom is sent to the pusher, which discharges it onto the mill racks. From the pusher, the bloom runs along to the inline weigher, where an accurate weight is recorded. It then continues onto the primary mill, the first of two reversing mills. The primary mill reduces the size of the stock by a series of passes and tilts, before feeding the bloom directly to the secondary mill. This again uses a series of passes and tilts to either produce a finished size for direct sale or a bloom or slab to feed into the 10-stand continuous mill. To improve the surface quality of the higher grade material, inline scarfing is used. This uses high-pressure oxy-gas to remove the surface defects from the steel. In order to present a good quality front end to the 10-stand continuous mill and remove defects, the front and back ends of each bloom are cropped off at the 1200-ton shear. These pieces end up in a pan and are eventually sent back to the Boss plant for recycling. After the shear comes the first part of the continuous mill, the roughing mill. This two-stand mill rolls blooms on the flat as feed for the next stage of the process, the intermediate mill. Prior to entering the intermediate mill, an inline tilter puts the bloom onto its diamond. The bloom then goes through the four-stand intermediate mill. Note, as in all parts of the continuous mill, the rolls are arranged alternatively horizontally and vertically, which ensures the best possible product for the customer. At the exit of the intermediate, the assistant roller calipers the product to ensure the correct size is being produced. From the intermediate mill, the bloom, now up to 90 meters long and still on its diamond thanks to unique V-rolls, runs towards the finishing mill. This four-stand mill produces the final saleable product, with the roller being responsible for ensuring that the product is in line with customer requirements. At the exit of the finishing mill is the billet flying shear, which cuts nose and tail crops from the product and also shears it into user lengths as determined by the customer order specification. The billets then run through an inline stamping machine which hard stamps the cast number on each billet. For slabs and billets greater than 140 mm square, the route avoids the finishing mill, and instead the steel goes across T3 transfer, facilitated by dropping the V-rolls, and through the bloom flying shears, traditionally known as P9. One feature of the huge size of the mill is that the shift craft teams have to use mobile plant, in this case a golf buggy, to get from job to job. Once cut into user lengths, the billets run down the racks to be gathered together against a raised stopper, in what is traditionally known as ingot packs. It's here that bar sorts are carried out. Next, the packs move across either T4 or T5 and down the racks to the cooling banks. The steel is then pushed onto the banks using hydraulically operated push-ons and pulled down with rope-driven transfers. The steel is left to cool for a period determined by its size and quality. Whilst the steel is on the banks, it is marked up with special chalk by the bank's team leader. This marking ensures correct identification is maintained and appropriate cold processing identified. When ready, the steel is pulled off the banks and run down the racks to water-filled quench tanks. Here the steel is immersed in water to bring the temperature down so that further inspection processes can be carried out. Once out of the tanks, there's a choice of routes available. Slabs go primarily to T18 and are visually inspected. Some lower grade billets such as melting base iron go via the visual inspection route. However, all the higher grade material such as tyre cords, leaded free cutting and forging qualities go via the automatic inspection route. Billets exit the tanks and run via racks to T6 transfer. From here, they are fed into the automatic inspection line. At the start of the inspection process is a roll straightening machine, which uses vertically inclined pairs of rolls and hydraulic pressure to straighten bars up to 160 mm square. However, some billet qualities, or those where the customer demands better than commercial straightness, are straightened by the offline gag press before further processing. After the RSM, the bars then run through an automatic shot blasting process and on into the Thermomatic house. The Thermomatic, which was installed in 1989, uses state-of-the-art technology and computer systems to automatically detect any defects in a bar that fall outside the customer's ordered grade. These defects are automatically sprayed with white paint to identify areas for offline rectification. Bars then run down the rack to transfers and are moved across into Process Bay 2 for further processing. At the end of the inspection line, each individual bar is colour-coded according to its chemical composition. This, in addition to the hard stamp, enables cast integrity to be maintained. Bars that are marked up as having defects require further processing before being dispatched to the customer. Rectification is by grinding, and there are 5 grinders in the Bloom & Billet mill. The first machines were built in 1980 in response to increasing customer demand for a higher grade product, with the last machine being built in 1995. The grinders use a high-speed rotating stone to remove the defects as the bar passes underneath on a rope-driven carriage. The prime bars can then be loaded out to the customer. Using these machines, high-quality forging billet up to grade 6 can be supplied to feed specialist markets. In addition to the removal of surface defects, customer specifications demand internal cleanliness checks, often to a very high standard, as in steel destined for hydraulic applications. Ultrasonic testing is carried out to ensure that customer standards are met and satisfaction guaranteed. As mentioned earlier, the majority of slabs rolled are processed at T18. If appropriate, rectification is carried out by de-seaming, whereby oxygas is used to remove surface defects. As well as the rolled product, mill personnel handle up to 20,000 tonnes a week of billet cast product. This material requires defashing, burning and painting up before dispatch. Once the steel has been processed to prime, then it can either be loaded out immediately or penned awaiting transport. There are many stocking pens in the mill, with a total capacity up to 50,000 tonnes if required. Steel may be loaded out by lorry or by rail, both internal and external. Once a string of wagons has been loaded correctly, the pins put in place and the steel strapped down, then it's ready to be dispatched from the mill. The FEC controller will talk directly to the traffic controller and organise for a loco to come in and pick up the wagons. From the mill, the wagons go across a weighbridge and hence onto main line for final delivery.
ఈ వీడియో మీకు నచ్చినట్లయితే లైక్ చేయండి, మీకు తెలిసిన వారితో షేర్ చేయండి. ఇలాంటి వీడియోస్ మరిన్ని చూడటానికి మన ఛానల్కి సబ్స్క్రైబ్ చేసుకోండి. పక్కనే ఉన్న బెల్ ఐకాన్ క్లిక్ చేసి ఆల్ నోటిఫికేషన్స్ సెలెక్ట్ చేసుకోండి.